solve a triangle? A? Thank you very much. Angles, sides, and area. Very good. Next page. We're going to take the sine of the side, sine of A over B. Sine. Solve both for H. We get H is D sine. Since they're both equal, you can set them equal to 1 D sine equals A sine B. Now it's choice. I do that, and we get that guy. Stop it. Oh, stop, stop, stop. Versions of the law of sines. They're basically the same thing. We know that if A over B equals C over D, then B over A equals D over C, you know? Whose phone is on?
Before I step on the phone.
Sure. It is a good phone. Now, the key way to remember this is the angle A is opposite side A. Now, the notation convention is this. We always denote vertices with capital letters and the side opposite in its little letter format. So little a is always opposite capital A. Little c is always opposite big C. You understand that? Yes or no? Thank you. So it really doesn't matter if it's in this form or this form. Depends what you're looking for. And then you could just use inverse trig if you wanted to solve for the given angle. We'll look at that with some of the practice problems we do, don't you know? Okay? Now let's do this. Let's take some things here. We're going to take a leg here and another part of a triangle here, and then we're going to take a third part of a triangle here. Those are three separate parts. And I really do have a better presentation of this, but you know what? I don't want to put it together right now. So we're gonna take a triangle down to the chop shop here, and we're gonna take it apart, and I'm gonna get three separate sides, right? Three separate sides. I chop out. Let's take a red side or a green side here, and then we're gonna take a red side here. We're gonna take a blue side, and then we can take a blue angle. And then we could take a red angle, and then we could take a green angle. And A is usually written this way. Yeah, I think so. I'm pretty sure. I'm not familiar with language. Yeah, kind of goes like that. Yeah, so I got blue angles, red angles, and green angles. So I can make infinite cloners here. Infinite cloners. That guy's now infinitely cloned. You know, sometimes we wish we could clone ourselves, then we'd have to live with ourselves, and that sounds scary to me. Yeah. One of me is usually more than I can deal with. So now we're all infinitely cloned. Isn't infinity an amazing number? Man, concept. All right, Chris Bueller, build me a triangle, 3 parts out of 6. Give it to me, dog. He's saying take one side of each and use these 3 sides, and I've got myself a unique triangle. Okay, David, give me another type of triangle, 3 different parts. A blue side, blue angle, and red side. Well, is it important that I do this side, angle, side, or is this anything different? Oh, your favorite. It does matter. No, color doesn't matter. What matters is its position. If I write it like this, Sydney, it says that the given angle is between the two sides. This means angle side side. The angle is not between it. See, it's not between it, is it? Still not between it. Now it's between it. All right. Don't care about the color. Green, give me another one. So I start with an angle. Then I take another side. Doesn't matter there, does it? And then a different angle. Okay. Good. Abigail, darling. Angle, angle, angle. All right, I can build a triangle or 10,000 with this. Okay, good. Lanny, give me a color, darling. Give me a color, darling. Red side, blue side, blue angle. Okay. Dirk, give me something. Red, blue, or green? Red. Blue. Green. Okay. Joe Ray, help me out here. Yes, goodness. Yes, gracious. Give me some colors, please. Red. Green. Green. Can't use the same angle twice, you big silly. Blue. All right, Vanessa. If you're born down south, it'd be La Vanessa. Red angle. What, hon? What color? Blue side. Green angle. Well, that's kind of like this one, isn't it? We can kind of group these guys together, can't we? Yeah? Okay. And this is the same as this. It's just spelled, well, no, that's not. That's two angles on this side. Okay. Huh? AAA? Oh, this guy? Oh, this guy. That's kind of the same thing. Okay. Oh, dude. All right, dude. There we go. All right. Okay, what else? How many of them are there? How many ways can you combine 6 things using 3 at a time? I don't do math in Knowledge Bowl. A, B, C, D, E, F. Choose 3. Give them to me. A, B, C, D, E, F. All right, I like what Sydney's doing, and this is the way I count these. A, B, C, A, B, D, A, B, E, A, B, F. Order doesn't matter. Then what? A, C, B is the same as A, B, C. This is a combination of B, C, D, B, C, E, B, C, F. C, D, E, C, D, F, C, D, F. Any others? And D, E, F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Any others? Position doesn't matter. Oh, you want decision? All right. All right. This is taking a lot longer than I want. Well, these combinations we saw in geometry, we saw a few that guarantee what's called triangle congruence. How many different triangles can you make using those parts? Which one of these guarantee triangle congruence? Remember that? Side, side, side is one. Side angle side is one. Two angles and a side in any order. That's it, isn't it? Two angles and a side in any order. Side, 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 or side angle side. These things guarantee triangle congruence. If you're not given these things, there may be more than one triangle that you can build with it, or in fact, no triangles at all. So this slide is here to tell us if we're given this, use this law. When do we use the law of signs given? Anybody know? Two angles in a side in any order, or side, side angle. And with that one, I better write, and we're going to learn this today, very careful here. If it is it there? Okay. You have good eyes, my friend. When given, we know to consider the ambiguous case. Now, what does ambiguity mean? What is ambiguous? Women. I'll come up here at me, ladies. Women are purposefully unclear in their outcome. You want to hear my example? I asked my wife, very romantically, will you marry me? She's rather ambiguous about her response. I don't know. I finally got her to agree with, I guess so. The enthusiasm was overwhelming. Feeling love tonight. There are three formulas you'll need for the ACT on the area of a triangle. One is the basic half the base times the height. The other one is this derivation here. Any old triangle, you got your base, you got your height. We could always find the height by taking this side, b, times the sine of that angle. Or we could just write the formula in terms of the given parts where we don't even have to find h. Since b times the sine of a is h, we could substitute it and we'll get one half BC sine A. That is not the way to write half sine times the given side times the other given side. One half the product of the sides times the sine of the given angle. And notice here that what are we given? We are given, when you're sassy, use this formula, SAS. You like that guy? He's got a good accent, doesn't he? Okay. I think I saw this on the practice test. Maybe it was a different one. You ready for the next page? No, please, no, no. No. La da 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 da. There it is. What? Are we done yet? That makes a lot of sense. All right, your next journal is going to be digital. I want to put into your phone and text it to me.
Okay. What? I don't like texting. It's really cool.
I will tell you this, that within the next 5 years, that the ability to have voice recognition is going to change how we text, isn't it?
We're all going to have arthritis if you go older.
I would say that your children are probably not even just saying it, they'll just think it. Would it?
No, probably not.
That's why we're in trouble as it is now. We've got all these safe ways to stab each other in the back. Ooh, check out my Facebook. All right, here's an example. No, I'm just, it's none of your business what's on my Facebook. Delete the people? Yeah, but there's a problem with that. Because their friends may be one of your friends. Yeah. So let's say you got on your Facebook and said, Dan Wagner's a turkey. But you deleted me from your Facebook.
Well, no, you don't delete them so you can talk crap about it. You just delete them so they can't see what's going on with your life.
Yeah, but if you're...
And if you happen to talk crap about it.
All right, I won't get into this. All right, so on this one, I've got 2 angles in the side. And so it's important that we identify what we have. And so I've given this side here, and this angle here, and this angle here. And I know that given 2 angles in the side, I'm going to use the law of sines. And I'm done when I've solved for the missing angles and the 2 sides. Well, it's easy to get this third side. We're just going to take and subtract the sum of the 2 given from 180. Booyah! So I'm going to build a proportion. I like to put my desired unknown in the left-hand corner. It just simplifies things. Basically, this guy here, this cat here, he moves out and goes over and hangs with this dude. Now, there's an important thing here, and it's called storing your answers, because the calculator is going to show you 9, but store 10. And this allows the truncation error not to be propagated to a degree greater than, say, to a millionth degree. So what I want to do here is I want to store this, seeing the store button, I want to store it for what I solved for, which was C here. If I do that and then use them later, it saves me time and I don't have error. Okay? This is what you guys did in your homework, right? Nice thing about the calculator, you can hit second enter, bring it right back up. This is the same, just change this. So 7 times the sine of 83 is that. Now once I find this, I'm going to hit the stow button, and I'm going to store it in for A. See what I did here? I stowed it. Stow. Yo. Stow. And if I do that, then I could just pull up 1/2 BC sine A. 1/2 the product of the given sides times the sine of the included angle, and I've got my area. Will you count us wrong, Mr. Wagner, if we're not correct to 3 decimal places? Yes, I will. But are you at what? Clear as mud? Most people find the law of sines, who understand it at least, very boring. I do too. It's just a lot of punching into the stupid calculator. When you get up tomorrow, have a nice breakfast, not full of carbs. Don't eat a lot of Mexican food. Unless you really, really like jalapenos. Watch what you have for dinner tonight. Unless you want to sit there very uncomfortable tomorrow for about 3.5 hours. Get a good night's sleep. Leave your phone off in the car. You don't need the distraction. Think positive thoughts. It's just another stupid test. Get a little exercise before you go in. Get your blood up. Who is that man? It is not John Wayne. He is a World War II veteran. He's about 5'2". He was 16 when he joined the Army. I do have a sound for him. I went and copied it. I just have to find it. Bear with me, people. I know this is more important than anything else we can learn today. Not there. Anybody know who it is? It's not Clint Eastwood. Nobody knows who he is. Can't tell you. Huh? It is not George. He owned the Texas Rangers for a lot of years. Well, stop whining. I can't find it. He's one of the silver screen Cowboys. He was on the same time that the other one who had the horse named Trigger was on, was married to Dale Evans in real life and on the screen. He was 5'2", so they had to have a lot of actors around him that were shorter. He had a recording career, even though he really couldn't sing. He was one of the singing cowboys because they'd go shoot the bad guys and sit around the campfire and sing. His most famous song was actually, Here Comes Santa Claus, Here Comes Santa Claus, right down Santa Claus Lane. It's Gene Autry. Great baseball man. He owned the Texas Rangers. All right, so anyway, that's Gene Autry. And I'm getting old. What are we given here? We are given side angle again. And so why don't we go ahead and find the obvious, which is A, 16 degrees. We get that by taking the sum of the two given angles and subtracting from 180. And the horse says something too, I've forgotten. He says, nay. So start with the obvious, and you want to build it. All right, I heard you, Gene. Now go away. Go over here. Thank you. Stop. Come down here. Thank you. I'm tired of looking at you, handsome devil. The horse says this. The horse says, come on, horsey. See the horsey? That was Champion. That was the name of Gene Autry's horse. Which, if you didn't know who Gene Autry was, you wouldn't know that his name was Champion either. Pretty good horse imitation, wasn't it? Want to hear it again? Yeah. That's why it's such a good imitation. What'd you think? It was me? So once we find the angle, we're given law of sines because we've got two angles on a given side. So we're going to start by building proportion. Let's find B. Okay. You could have found C too. Doesn't matter the order. Just find it. And once you find it, what am I doing over here that's so critically important here? What am I doing there? I am storing for C. And here, what am I doing? I'm storing for B. And the reason I do that is so I don't propagate the error through truncation. So when I come down here, I can just go ahead and plug them in and find my area. Don't truncate it. You'll be off by a couple, 3 decimal places, and I'll be taking 2 points off in every answer on the test. Sorry, Charlie. I got to get you ready for AP. 999. 20. So I've solved for this triangle. That enough? Need another example? Wait. No, wait. behind there? Oh, that's just the thingy. How America's changed. Every Saturday to watch that guy. White hat. Bad guys wore white hat. Bad guys wore black hats. Good guys wore white hats. What are you, JJ? You're in the middle. You're a mediocre guy. I'm trying to do an equal opportunity because I've been doing Cowboy, so I've got to do. These are not Indians because they're not from India. They are Native Americans. They're actually, in this case, they're Native Canadians. The picture is indeed distorted. These came out of the Northwest, these peoples. It's interesting that they have traditional clothing on, and the women don't look happy because they're still subjugated to the men. But they're proud of their pottery. Their mother is banging them over the head with a pot so that they have flat heads. I think that's happened to some of you. A little too much head banging. There is something that goes with it. Picture was distorted. So what I've got here is I'm given angle, side, side. Now on this one, we'll have to talk about this a little bit because it is ambiguous. But in this case, we might have two such angles, but we'll have to get back to that. So we'll do some more of this. I did have some tribal sounds here. I don't know where it went. Pretty good sound too. So basically what we're going to do is this one's different because we're given two sides, and we're going to look for an angle. And so I want to find angle C, and so I start with sine C over 21. Remember opposites. The sine of the angle divided by the side opposite equals the sine of an angle equals the side opposite that angle. See what I'm saying about opposites? Yeah? So cross multiply, take the arc of sine, and make sure you're in degrees. And then store it into C. I stow into C. Store it into C, and you won't have to do it again. Okay? Okay. And then you can find your area. Piece of cake. Let's see what happened to my Indian sound. You know how they got called Indians? Anybody know that story? Christopher Columbus thought, I'm in India. Look at those funny looking Indians. And stuck. He was a smart guy. He knew how to survive in a tough time, didn't he? Naming little ships after saints. Most of you probably know that the original settlers of this part of the country were from what country? Spain, Mexico, work north, and working the land still in places like Argentina, the gauchos, the whole word macho, rancho. We owe a lot of this to our Latino heritage friends, and this is to pay tribute to that. Okay, this guy's out there working the horses, caballos. And so there was a sound on this one too, but I lost that one. On this one, what we have is angle, side. Well, notice that the side opposite the given angle is bigger than the other given side, so this will tell me I've got one unique triangle. What's that? I can't hear you, dear.
Where did the 27 come from?
The 27 came from Mars. Yeah, it came from Mars, and I don't know, sine C over this. Sine C over 27. I don't know or not. I don't know. It's gone now. It's like What are these guys doing?
Branding a cow.
Now, these are real cowboys. You can tell because their pants are rolled up to their knees. This is before baggy. Who's bagging in here? Dirk? See these guys' pants? That's how you're supposed to wear them. There's a belt that goes above the butt. Okay, they don't feel more manly if they show each other their boxers. In fact, my guess is they're wearing whitey-tighties. This is a horse specially trained for this type of work. He is called a quarter horse, specially trained. They're very valuable. This guy has the best job because he's not doing what they're doing. This guy's branding, and this guy, he's holding the head down. And what's this guy do? This is the job I had. Okay? This is the poop target. Whenever I go up and help my cousins branded in Montana, this is the job I got because I was always the least experienced. I couldn't run the quarter horse and I couldn't run the branding iron. That was the oldest cousin that had that. Even my older brother got this one. But I was always the poop target. So what you do is you take your left leg and you stick it right up there over the bunghole. Because I tell you what, when they reach down and cut these little jewels off, then you stick some scalding hot iron on them, this calf will do two things. It'll break your heart, and then it'll poop on you. Anybody here ever brand besides me? It's a true story. So after the first 2 or 3 times you get shot with this flying crap, you learn to take your boot and stick it right there. So you grab the top leg with your hands and your arms, and you take that right foot and you stick it right up its butt there. And you take the left leg, and where do you put it? Where do you put it? Right here on this other leg, because the minute you cut its nuts off, it's going to kick you in yours. Now, how did I learn all that? You think my loving cousins would tell me that? The ones who would take my brand new cowboy hat and drive over it with a Honda 90 just to say I was a dude? They would laugh their buns off at me writhing on the ground. It's a lot easier to learn it the easy way. All right, I'm tired of this. We're done. Yeah, we're done with that. Just another example. What are they doing? They're communicating with their gods. They're praying. Talking to the spirits. These people are much more in tune with their surroundings. They understand the change in the breeze, the color of a trout. We miss that. I really do. So, anyway, that's enough of that. Wanted to get that in. Now let's do the next one. Suppose I ought to pass this out. The ambiguous case. Anybody see the recent Sherlock Holmes movie? Did you like it? Anybody read the books? They're much better, aren't they? Yeah. Well, let's see. I've got some stats. Today we're going to learn how to determine the number of solutions we're given two sides and an included angle. We have to do some detective work. Hence, I put this man on it.
My life fails its stagnation. Give me problems. Give me work.
And who is that? That's Sherlock Holmes. And this guy is Dr.
Holmes, there looks to be a case of the ambiguous case.
That's pretty good, wasn't it?
Who was that?
That was me. Thank you. Now, it isn't scary. It's a little frightening. That's a pretty good slide, wasn't it? Look at this. He's in the smoking car. You guys don't remember this, but they used to have smoking in restaurants.
I remember that when I was little.
They have a smoking and no smoking section. And the smoking section is right next to the non-smoking section. The smoke has this terrible habit of moving. Yes. Explain where we encounter the ambiguous case. There they are. The dynamic duo. They're slowly fading from reality like we all have a want to do as we pass from this dimension to the next. You know, we are having to deal with the ambiguous case, and we were given two sides at an angle not between the two sides. We need to consider how many triangles may be made using the given part. So in short, guys, this is nothing more than one more step. One more step. And so after we do that step, then we use the law of sines and solve the triangle. So if we've mastered how to solve a triangle, all we're doing is one more step. And that is how many triangles are possible. So I remember pulling this slide off here, this picture. I thought it was rather nice. Study of color and shadow. It's London, you know. The Thames. London Bridge. And guess where this is? Huh? Buckingham Palace. So we're going to slide it this way. It's going to slowly fade away. And so I want to give a case of ambiguous case. So what do I have to be given? I got to be given angle and side and side. Is that ambiguous? Is that ambiguous? Alrighty. Is this ambiguous? No. All right. That's the game I want you to play. David. Thank you for volunteering. Will you go up, sir, and drag your little three parts over to create an ambiguous case given three parts? Sydney, you're next. And then Sire, you're after that. You're going to take part A. You can't do what I just did. Cheater. He's going to take angle B. I'm not telling. No, I'm not. Three things. There's a problem. Sit down now. Is that ambiguous? Tell me now. No, why not? We're given side angle side. Is side angle side spell ASS? No. Sorry, David. Oh, no. Oh, no. Who's next? Who did I say is next? Who did I tag for nextness? Sydney! Will you please, darling, Please. Please. Today. Thank you. She's going to take 3 parts and she's going to build the ambiguous case. Side A. Side B. That is side C. You can't put a side where the angle goes, Sydney. Is that ambiguous? Is it possible? No. Thank you, Sydney. It is not possible. Why is this impossible? Because side C has to be opposite. So B would have to be here, Kalo. Sorry, dude. Sire hyphenated last name. You're up. Now, Sire's going to marry a woman named Francesca de la Rosa. So she's going to hyphenate her name to Francesca de la Rosa Silvas Garcia. And they're going to get married to a guy named Martinez. He's taking angle B. B. He's taking side B. And he's putting it opposite of B. You big silly. Pay attention. Pay attention, Sire. Thank you. It always has to be opposite. Put it anywhere. There you go. Is that ambiguous? Yay. Bueller, you're up. Bueller. 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 Hold on. Hold on. All right. It's like a booger. It's not letting go. Okay. You're up. Wait. You broke it. Okay. B is in Bueller. Little b opposite big B. Very good. And any of the other 2 sides. Oh, you broke it. Great. Good. Angle side. I think we've done what we came to do here. Thank you very much for playing. Actually, we learn more from doing it wrong than right. Isn't that cute? It's adorable. It's a dynamic look. What does dynamic mean? It moves. Where does it move to? There it is. Okay, here we go. Waiting. Okay. Now, I've got this presentation for you. I worked hard on it, so thank you very much. Now, this is what I'm given. I'm given this angle. See this angle? I can't change that angle. That angle doesn't change. Does this angle change? No, I'm given this side length. See that side length? That's a given side length. It doesn't change, does it? And this is the third side. Notice that this is the same as this. Want to see? Say yes. It's longer, it's shorter, it's shorter, it's longer, it's longer, it's shorter. See, it's the connect. Same thing, right? Okay, right now this is less than this, isn't it? So what I'm going to do here, y'all, is I'm going to swing this up and down. And when I hit this other side here, I got a triangle, right? Okay. So tell me when I hit this here side. I'm waiting. It doesn't, Mr. Wagner. It's too short. You got to make it longer. Tell me now. Right there. There's my triangle, right? Does it hit it again? Does it hit it over here? No. How many triangles can I make? 1. Okay, good. Very nice. Let's make it a little shorter. Let's make it a little shorter. There's 1. Uh-oh. There's 1, and whoop, there's 2. See that one? See it? And there's what? There's another one. See it? So I made 1, didn't I? I made another one, didn't I? All right, let's make it really short again. How many can I make? None? Let's make it that long. Longer. How many can I make now? What kind of triangle is that? Right, let's make it longer than that, but shorter than that. How many can I make? 2. There it is, simple as that. So what we're going to do is we're going to take this side. Now this guy is really important because he is opposite the given angle. Opposite the given angle is the key. Where is this side? Opposite the given angle, and it is the key. Now let's say that this side opposite the given angle is shorter than the altitude. See this H thing? It's the altitude. Let's say it's shorter than the altitude. And what's your conclusion? How many triangles can I make? None. So if the side opposite the given angle is shorter than the altitude, then No triangle possible. We'll get to the notes on this in a minute. You want to just watch and see. If the side opposite the given angle is equal to the altitude, then one right triangle. Now, here's a big one. Here's a big one. Look. Stop, please. Thank you. Let's make this other side, the side opposite the given angle, bigger. We'll make it bigger than the other given side. See, it's bigger than the other given side. Do you believe me? See, it's bigger than the opposite side, or the other given side. And how many triangles do you get? One. So we get no triangles, one triangle, or two triangles. When does this occur? When this side is bigger than and shorter than that. And that's the ambiguous case. Isn't that a nice demonstration? Say yes, Mr. Wagner. Thank you for putting that together. So after we say 0 triangles possible, meaning no solution, or we say 1 triangle possible, or we say 2 triangles possible, then we have to solve the triangle. And what's hard for us is finding both triangles. Now here's that relation. Let's say there are 2 triangles possible. You have to solve this guy and you have to solve this guy. Now what's the relationship between this angle right here and this angle right here? I'll show you. They are supplementary. See? Now watch what I'm going to do. I'm going to take this guy and I'm going to flip it. Let's try. See? And what do you notice? Yeah, they're supplementary. They are supplementary. And this is the angle you have to find first. Right here, you draw both pictures here. You find this one first, then you find this one. How? Supplementary. Supplementary. There, you've learned everything you need to learn. Isn't that pretty? Oh. Give a general process of how to determine how many triangles may be created when given 2 sides and a non-included angle, ASS, if you wish. 1, determine the height. How do you determine the side? The height? B sine A. The side adjacent to the angle times the sine of the angle. That's your height, B sine A. The sine of this angle, A, is H over B, so H is B sine A, yo. But after you determine the height, you say, if the side opposite the given angle is shorter than the height, then no triangle is possible, no solution. Well, let's say that A is bigger than H. Well, if A is bigger than B, then A has to be bigger than H, no duh. If the side opposite the given angle is bigger than the other side, you have 1 triangle possible. Only 1. So go solve the triangle. You solved the mystery of the ambiguous case. Elementary. And the part that gives us 2 parts is the part that says if A is greater than H, oh, whoops, I forgot that one. If A is equal to H, then 1 right triangle is possible. Well, then use right triangle trig to solve it. No need for the law of sines. If it's a right triangle, just use the law or the right triangle trig rule. Sokatoa. She is Sokatoa. He is from China. And the last possibility is if A is greater than H, but the side opposite is less than the other given side, then there are 2 triangles possible, and yes, you have to solve for both of them. So on the test, I'll give you a couple of ASS's. And in watching yours, you will determine how many solutions there are. I'm not telling you. You have to figure that out on your own. Any questions on this? Are we good, ja? Are we good, ja? He's good, ja. Ja. Ja, ja, ja. Did you see what the Ukrainian parliament did? Well, they passed an unfavorable law, and so the people that voted against it came in. The senators came in and threw eggs and smoke bombs at the poor leader, Speaker of the House. So he stood up there with an umbrella. We're such a civilized species. How do you solve an oblique triangle when given side, side, and a non-included angle? And there are two solutions possible. Well, this is how you do it, 5 steps. First thing you want to do is you want to draw and label two triangles. One of them will be obtuse, and one of them will be a little cute one. Put the parts in that you know. I always like to put the given angle in the left-hand corner. That just keeps things nice and squared away, standard if you wish. Draw your pictures. And after you draw your pictures, you determine the angle opposite the other given side. The one in the right-hand corner. We'll use law of sines. The angle opposite the other given side. After you do that, the corresponding angle in the other triangle is a supplement to this angle. Wasn't that a nice way to say that? I thought it was very clear. Find the one, they could supplement to find the other, bottom right side. They're related as supplementary angles. Now, Lisa, earlier I said, what does supplementary mean? You said they added up to 90, and I got to wait. I know, I got to wait for you to remember that. Doesn't CO start complementary? And doesn't CO rhyme with 90? CO 90? You with me? All right. CO 90, we are complementary. That's why we take math, pick up lines. Hey, baby, let's get complementary. You, me, CO, we add up to 90, and that is right, baby. Later on, we could talk about getting supplementary. Supplementary, yeah. You ever see a 180-degree angle? We were lying down. Step number 4, after you determine that one, let's go ahead and find the missing sides and angles. I'm not going to delineate this. That's pretty obvious. We've been doing this. And then determine the area. We have two triangles. Find the area of each. It's just two problems in one, the ambiguous case. This is pretty simple stuff. Are we good? We are so good. So who's doing what this summer? Anybody doing a summer camp somewhere? Can you? Good for you. Take lots of pictures. Take pictures. Run from lions. Starving Africans. All right, well, it's kind of a London theme, Sherlock Holmes and all. Anybody know who that is? What bridge is that? Does it look like it's falling down to you? Anybody watch the movie Dick Tracy? Yeah. Remember the last scene? Yeah. Yeah. All right, so let's see here. I'm going to draw a picture, aren't I? Oh, I worked hard to get this sound. Everybody sing. Come on, let's hear those golden pipes. My fair lady. We should get up and play. Everybody up, let's play. Come on. You guys are about as fun as a sack of cactus. Okay. So we draw a picture. And I'm a little bit out of scale here. And I don't care. It'd probably been smart to do so. But I always put my given angle in this corner. In order for us, and this was demonstrated earlier, that if it's going to be ambiguous, one of the given sides has to be opposite the given angle. So I'm going to put that over here. And then, of course, I just slide the other given side up in the top left corner. If we look at it the same way every time, it's going to be easier to understand. So I say, hey, that's ambiguous. I have to do a step first, and that step is to find the height. And the height is found by taking this side 4 times the sine of this angle. And I find that it's 3.921, which is, oh my goodness, greater than the side opposite. So since the side opposite the given angle is indeed less than the altitude, we say no triangle possible. Huh? Yes, dear. No, they're not. The only question that's dumb is one that's too dumb to ask. Why do I use the 4? The 4 is a given, hon. Because if I do this, and this is a good question, you're not seeing where I'm coming up with this equation. So, Leanne, what I want to do is you look at this angle and look at this triangle, right? So if I start by taking the sine of that 122 degrees by the definition of sine, we said it's the opposite over the hypotenuse, right? But we're looking for h, so we cross multiply the sine of the angle, the side adjacent times the sine of the angle. That's how you find it. So that was a good question, dear. You're welcome. We heard enough about London Bridge. Does anybody know how to play London Bridge? What's the matter, David? You look like you're hurting over there. It's a fun game. You ever have to entertain a bunch of 4-year-olds? They love it. They'll play it all day. They giggle every time. Oh. Another painting, Westminster Abbey. There was a lot of them. This is classic. It's classic and tragic. I don't know if you've ever read Ken Follett's work. Gosh, I wish I could remember the name of that book. About 900 pages, the sequel. Pillars of the Earth. You ever read that? Pillars of the Earth talks about the building of shrines to oneself, to one's God. Westminster Abbey. This is a church. It is huge. It's huge in cost. You got to remember when this was built, people were living in mud huts with thatched roofs around here, and they'd be asked to come in and work and build this. But the engineering is amazing if you look at it. If you think you're putting bricks together with coal and coal-fired ovens, and this is a painting. I mean, you got a road going in. There's obviously no landscaping going in. A little different than today. Don't you think? So we'll slide it to the left here. Art is amazing, isn't it? It captures our history in an interpretive fashion, unlike a digital camera. All right, so let's look at this guy. We've got given angles 45 degrees and 2 sides, and I will structure it. Try to put the given angle in this one. And the side opposite over here and the side adjacent over here. And so my first order of business is to indeed determine the height. So 7 sine of 45 is 4.947. We've got the situation that the side opposite of the given angle is indeed bigger than the altitude and less than this side, so there are 2 triangles. That's the first step. We good? We've determined the number of solutions. Is this making any sense to anybody? Oh, yeah. He's good. Exactly. This is one of the world's most famous landmarks. You look at this, you know exactly what it is. You know exactly where it is. What is it? It's a double-decker bus. It's only found in the United Kingdom, London town. When you saw this, you did not think Las Vegas, my dear. Notice that it is a modern double-decker bus. I'd be scared to death to ride. Have you ever watched Harry Potter when they had that scene? What a great scene. That's red, dear. I find this piece of ornamentation interesting. It's obviously a roll bar of some sort. Mirror, kind of neat. Anyway, it's double decker kebab. Mayor of London. Found a lot of different artwork on that guy. Will you stop, please? All right, goodbye. Say adios. Adios. I know. Shoulda, coulda, woulda, didn't. So here we go. And I know I've been yakking at you a long time, so just try to focus for one more minute. And this is the part that gets people. After you determine that there are two triangles possible, I go ahead and draw them both out. And I label all my parts. That's easy enough, isn't it? We good? Okay. After we determine all that, I'm going to start. What am I going to find first? What should I find first? This one right here. Find this first right here. Find first. See this guy? That angle? Find second. It's the supplement. It's the supplement. Yep. Take that number, subtract from 180. That's the supplement. Find third. Find fourth. Go forth and prosper. Then find fifth. Fifth. And then find last. That's how I do it. And that's what I do with my calculator. So you get good with your calculator. Build your proportion, solve for angle A, store A into your calculator, go find its supplement, and I stored it over here. Okay? Find your area. I've got two triangles here. There's one, and there's the other. Now, we can always keep in mind how to check these for reasonableness. Remember that in any triangle, the range of the sum of two sides is either, it's got to be bigger than the difference of the two bigger sides and smaller than their sum. So if I take and I find C and it's 46, since 7 plus 6 is not greater than 46, no, it's impossible. So you can check your work. Where do people screw this up? They truncate it. They go ahead and make 55.6. They round it, and they use that to compute all the others, and they'll jack everything else up. They tend to call ambiguous case whenever they see ASS, it's two triangles. So they say there's always two, but there's not. Then they'll go on to the next problem in the test, and it is indeed two solution case, and they'll do one. Big sillies. We good? Okay. So what did we learn today? Okay, let's say I gave you SAS. What do you know about that? What do we use? What do we use? Law of sines. What if I gave you one of these? Law of cosines. What if I give you one of these? Okay. So since we're taking the ACT tomorrow, I thought I'd better throw this at you just for grins and giggles. Let's say I'm given side A, side B, side and angle C. And that's side angle side, isn't it? So to find side C, we use this guy. It's simply a Pythagorean theorem with an adjuster. one side squared plus the other given side squared. Doesn't that look familiar to you guys? Doesn't that look just like Pythagorean? It's not. If it's a right triangle, it is, but it's not. And so because it's not, we have to include the adjuster. And since it's the law of cosines, you better use the cosine. All right, so that's for your calculators, so you can program it in for your ACTs. Okay? So basically, in summary, if we're given side angle side or angle side side, we use the law of sines. If we're given angle side side, that's the ambiguous case. We need to first determine the number of solutions and then solve the one or two triangles. That's what we did today. Thank you all very much. Have a great day. Put